Hi, this video um, is about hypothesis testing with one sample. We want to go over chapter 9 in Introductory Statistic in OpenStax, which is talking about the hypothesis testing. So I will break it in two videos. In the first video, I will go over sections 9.1 to 9.4, which explain all the steps of the hypothesis testing. And in another video, I will go over the section 9.5, which is a full hypothesis testing, and we will have some examples with the complete hypothesis testing. So what is a hypothesis? Hypothesis in a statistic is a claim or a statement about the population. When we have a claim about the population, we have a hypothesis, and we do the hypothesis test or the test of significance to test the claim and to make sure that we can support the claim or we need to reject the claim. In every hypothesis testing, we always have two hypotheses or two statements as a hypothesis, which is called the null and alternative hypothesis. Null and alternative hypotheses are always two contradictory statements. One of them is always the claim, and the other one is it's the contradictory with the first one, which is the completely opposite. Null hypothesis, which we always show with H naught or H sub 0, is a statement that the value of population parameter is equal to a claimed value. So remember that hypothesis test is a test about it is a test for a claim on the population. So everything that the notation that we use for the null and alternative hypothesis are the notation that we use for population, like population proportion, which we show by P, or if it's a population mean, we show by mu. If it's a population standard deviation, we show by sigma, or if it's a variance, is sigma squared. So remember, the hypothesis, it's a test about the claim on the population. So we are going to use a notation for the population always. So the null hypothesis is a hypothesis, is a statement which always have the equal sign. And the alternative hypothesis, which we show by H1 or HA or H sub A, it's another statement that should be different from the null hypothesis, but remember that we never put equal sign for the alternative. So alternative can have greater than or less than or not equal to, but if the equal sign always goes for the null hypothesis. For example, if we have a test about the population mean, so you know that we show the population mean by mu. So we always show the mu greater than or less than or not equal to in the alternative hypothesis, and the opposite of greater than is less than or equal to, goes for the null. If the alternative is less than, the opposite of less than is greater than or equal to, which goes for the null hypothesis. If the alternative is not equal to, the equal sign goes for the null. There is no equal sign in the alternative. Okay, and we always assume that the mu is equal to that claim number. Sometimes you may see in some homework problem or some books that for the null hypothesis they always put equal sign. That is okay as well. So instead of less than or greater than in the null hypothesis, we can only put equal sign. But for the alternative, we have to make sure that it's greater than or less than or not equal to. For example, it says that write each claim as a mathematical sentence, state the null and alternative hypothesis, and identify which represent the claim. Okay, So it's important that we show which one of those hypotheses is the claim. So the first one, it says it claims that the proportion of its students who are involved in at least one extracurricular activity is 61%. That's the claim. If I want to have a hypothesis test on this claim, I need to write the null and alternative hypothesis. The claim says that the proportion is 61%. Proportion means P. Is means equal to. So the claim says that the P must be equal to 61%, but we never keep the percentage in our writing, so we show in decimal. So the claim says that the P must be equal to 0.61. Where do we put the equal sign? Do we put it for the null or we put it for the alternative? Yes, we always put the equal sign for the null hypothesis. So the null hypothesis can be, or H0 or H naught can be P equal 0.61, and make sure to write that is a claim. And if the null hypothesis is equal sign, the alternative it's not equal to, because they should be the opposite of each other. Next example, it says a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, the mean time is less than 15. That's the claim. We show the mean by mu. Less than 15, that means mu is less than 15. That's the claim. Now the question is, after finding the claim, we need to know when we are writing the null alternative hypothesis, where should I have to put the claim? Since the claim don't have the equal sign, we put it for the alternative. So for the alternative, I put mu less than 15, and so if the alternative is mu less than 15, the null hypothesis must be the opposite of less than, which is greater than or equal to 50. And don't forget to write in front of the alternative, that's the claim. Because at the end of the hypothesis test, when we want to make our decision, we need to know that where the claim is, because it's different. If the claim is on the null, we need to reject. If it's an alternative, we need to support. So that's important that we know where the claim is. So the alternative is when mu is less than 15 and the null is greater than or equal to. Or you can only put mu is equal to 15 for the null hypothesis. That's fine. The third example, it says the company advertises that the mean life of its furnaces is more than 18 years. Mean more than 18. If I want to have the claim says that the mean or mu is more than 18. That's the claim. Now, after stating the claim, where do we put the claim? In the null alternative. Since there is no equal sign, we put it for the alternative. So the null must be the opposite of greater than, which is less than or equal to 18. Okay, so the first step for every hypothesis test is stating the claim, write the null and alternative hypothesis. After we figure out how we can write the null and alternative hypothesis, we follow the next steps. But we have another example. Let's finish this one first. It says, write the claim as a mathematical sentence, state the null alternative hypothesis. Okay. We want to test if college students take less than 5 years to graduate from college on the average. Okay. So what's the claim? The claim says that if college students take less than 5 years to graduate on the average means mean. So to write the null and alternative hypothesis, You need to use mu because the claim is on the mean, on the average. The claim says that the mean is less than 15. Less than 15, where do we put the claim? Since there is no equal sign, we put the claim for the alternative. And we mentioned it's a claim. So if the alternative is less than 15, that means the null is greater than or equal to. Less than 5, oh, I'm sorry. Less than 5 years, not 15. Okay. Now, next example. On a state driver's test, about 40% pass the test on the first try. We want to test if more than 40% pass on the first try. When we read this question, you don't see any word that tells you what notation do you have to use for the null alternative hypothesis. What is this test? Is it this test about the population mean? Is this test about the population standard deviation? Or is this test about the population proportion? Because we need to know the notation, the exact population parameter that we can use the notation. Since you see the percentage, anytime you see percentage, it tells you that is a test about the proportion. So we are going to use letter P for the proportion. And it says we want to test if more than 40%. More than 40% means since there is no equal sign, we put it on the alternative. Don't put the percentage, make sure to change it to decimal. And that's the claim. And if the alternative is more than, that means the null is less than or equal. Okay. Or you can just put equal sign. I told you you can only keep the null as an equal sign. But if it's a claim, you have to just write the exact symbol that we have. Okay. Now, after writing the null and alternative hypotheses, we need to take the test. We need to take the hypothesis test and make our decision at the end of the test. And our decision always at the end of the test is in two cases. We reject the null or we fail to reject the null. So I will show you in this video and the next video that how you can test the claim and how you can make your decision and how you can interpret your decision and write your final statement. But just remember, we always have two cases at the end of the problem. We reject the claim, reject the null, or we fail to reject the null. And if the claim is on the null, we are going to write as a rejecting the claim. But if the claim is on the alternative, we are going to use the word support and we say, okay, if we reject the null, we can support the claim. So we will see in the next slide in examples, it makes it more clear for you. Before we get to that part, we need to learn about the two different types of error that we may make. I told you at the end of the hypothesis test, we have two conclusions, rejecting the claim, the null, or fail to reject the null. But if we reject the null, and the null is the only true statement that we have, that means we are making a mistake. We are making an error, and that error is called type 1 error. And the probability of making that error is called it's alpha. But if at the end of the process we decide to fail to reject the null, if our decision is failing to reject the null, but the null hypothesis is not a true statement, actually it's false. So if it's false, it must be rejected, But your calculation shows that you fail to reject a null. You cannot reject a null. Again, that's another mistake, and that's another type of error which is called type 2 error. And the probability of making that mistake is beta. Beta is the probability of making type 2 error. So remember, type 1 error is rejecting the null when the null is true. Type 2 error means fail to reject the null when null is false. Because when null is true, it must be supported, but we're rejecting. That's an error. If null is false, it must be rejected, but we fail to reject. We cannot reject it based on our calculation. Again, we're making an error. So we have two types of error, type 1 and type 2. And everything is in this table. So if the null hypothesis is true and you reject it, you're making type 1 error. But if you fail to reject when it's true, that means you are making a correct decision. If null hypothesis is false, it must be rejected. And if you reject it, you're making a correct decision. But if you fail to reject, that means you're making another error, which is called type 2 error. Okay? Let's look at an example. It says, suppose that the null hypothesis is Frank's rock climbing equipment is safe. That's a null hypothesis. And it means that the alternative must be the opposite, which is the Frank's rock climbing equipment is not safe. If we will have a type 1 error, what we can say? What is type 1 error? Type 1 error means rejecting null when a null is true. When the null is true, that means the Frank's rock climbing equipment is safe. But we reject it. So what is type 1 error? Type 1 error is that the Frank thinks that his rock climbing equipment may not be safe because it's rejecting this, but in fact, it is safe. That's type 1 error. He thinks that the equipment may not be safe when in fact it really is safe. Type 2 error tells me that I fail to reject the null when the null is false. When null is false, that means the Frank's rock climbing equipment is not safe. But we fail to reject it. That means Frank thinks that the rock climbing equipment is safe when in fact it is not safe. Which one has more consequences? If Frank thinks that the rock climbing equipment may not be safe, for sure he's not going to use it, even if it's safe. But if Frank thinks that the rock climbing equipments are safe, we're going to use it, but in fact it's not safe. So in this case, type 2 error has more consequences. And you know that the alpha is the probability of making type 1 error. So the probability that the Frank thinks that the rock climbing equipment may not be safe when in fact is safe, it's alpha. Beta is the probability of making type 2 error, and that the probability that the Frank thinks that the rock climbing equipment may be safe when in fact it's not safe, that is beta. Another example, suppose that the null hypothesis, or H naught, is the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. So when the null says the victim is alive when he arrives at the emergency room, so the alternative is that the victim is dead when he arrives to the emergency room. It's not alive. Type 1 error means type 1 means reject the null when null is true. Null is true means the victim is alive when he arrives to the emergency room, but we reject it. That means the hospital crew thinks that the victim is dead because they are rejecting the null. However, the victim is alive. So the emergency crew thinks that the victim is dead when, in fact, the victim is alive. Type 2 error means fail to reject the null when null is false. Null is false means victim is not alive, victim is dead. But we fail to reject it. Fail to reject, that means they don't reject it. They think that the victim is alive. So for type 2 error, the emergency crew do not know if the victim is alive when in fact it's dead. Okay? Or the emergency crew thinks that the victim is alive when in fact the victim is dead. And the alpha is the probability of alpha is the probability of type 1 error. Beta is the probability of type 2 error. And which one has the more consequences in this case? Type 1 or type 2? If emergency crew thinks that the victim is dead when the victim is actually alive, they don't do anything to survive him. But if the emergency crew thinks that he's alive when in fact he's dead, they may do something, however it's dead, the victim is dead. So in this case, the type 1 error has more consequences. So next example says it's a boy genetic lab claim to be able to increase the likelihood that the pregnancy will result in a boy being born. A statistician wants to test the claim. Suppose that the null hypothesis it's a boy genetic labs has no effect on gender outcome. So if that's a null hypothesis, type 1 error tells me that reject this, however it is true. Reject that the genetic lab has no effect, however they have effect on the gender outcome. So type 1 error says that the boy genetic lab influences the gender outcome when in fact has no outcome. Okay, so null hypothesis means there's no effect. If it's true, that means the genetic lab has no effect. But when we reject it, we believe that they influence the gender outcome. So the boy genetic labs influences the gender outcome. Reject the null. However, the null is true. Type 2 error tells me that we fail to reject the null when the null is false. Null is false, that means the genetic lab has effect, has influences the gender outcome, but we fail to reject it. Okay, so we say that the boy genetic lab does not influence the gender outcome because we accept it. However, it does. It influences. Okay. Another example. Let's list this. Okay. It says a certain experimental drug claims a cure rate of at least 75% for males with prostate cancer. Describe both type 1 and type 2 errors and which error is more serious. Okay, what is type 1 error? So let's read the claim first. Read the claim, write the null and alternative hypotheses, and then after having both of the hypotheses, we can talk about the type 1 or type 2 error. The claim says that the cure rate is at least 75%. At least means minimum. That means 75% or more. When we have percentage, I mean, it's talking about the proportion. Proportion is greater than or equal to 75%. That's a claim. 0.75, sorry. And that's a claim. Where do we put the claim when we have equal sign? In the null hypothesis. So the alternative is that the P is less than 0.75. Now, when you want to describe type 1 and type 2 error, you are talking about the null hypothesis. Rejecting the null when null is true, fail to reject the null when null is false. Okay, for type 1 error, I am going to reject the null when null is true. When null is true means that the cure rate is at least 75%, but I'm rejecting that. So I reject the claim. I say that the cure rate is less than 0.75% when in fact is more than 75%. Type 2 error tells me that I failed to reject a null or do not reject a null when null is false. So if you do not reject the null, that means you accept the null. So you say the cure rate is at least 75%, when in fact is less than 75%. Okay? Or let's look at this example. It says a certain experimental drug claims a cure rate of at least 75%. Oh, that's the same. Okay. Now, after writing the null and alternative hypotheses, we need to know what type of test are we going to use. We will have two types of tests in this semester, the z-test or t-test. If you remember in chapter 8, when we talked about the confidence interval, we talked about the z-test and the t-test, z-table and the t-table. And to find the confidence interval for population mean, if the sigma was noun, we were going to use the z-table. If sigma was unknown, we were going to use t-table. That's exactly the same here. And also for the confidence interval, we said for finding the confidence interval for population proportion, we are going to use the z-table, and we do the same here as well. So the tests that we are going to use are the z and t. Z-test is for population mean when the sigma is noun or the population proportion. T-test is just for population mean when the sigma is unknown. And after finding the test that we are going to use, we need to check the requirement and write the formula, plug in the numbers, and take the test. So for population mean, when sigma is noun, that I said that we're going to use the z-test. And that is the formula that we're going to use. Because the test, the claim is on the population mean, we're going to use the mu, x bar, which is the mean of the sample, sigma, which is the population standard deviation, because the sigma is noun for us, and the n, which is the sample size. But don't forget, anytime you want to use this test, check the requirement, and the requirement tells you that the sample must be random, and the population must be normally distributed. If it doesn't mention, make sure the sample size is more than 30. After you check the requirement, you are going to use the z-test by using this formula. But if we had a test on population mean, but the sigma was unknown, the sigma or the population standard deviation was not given to us, we're going to use a t-test. And that's the formula that we use for t-test, because the only difference in the formula with the z is that when sigma is known, we use sigma, but if sigma is unknown, we use s, which is the sample standard deviation. The requirements are still the same. We need to check that the sample is a simple random sample, and also we need to check that the population is approximately or normally distributed. If not, the sample size is more than 30. But if the claim is on the population proportion, again, we're going to use z-test, but with this formula, because the claim is on the population proportion, we use p for the population proportion, and we know the p hat is the sample proportion over the square root of p times q divided by n. And to check the requirement, we are going to check the same requirement that we had for the confidence interval. The sample must be random. The question must meet all the conditions of the binomial distribution, or the n times p and n times q must be more than 5. After checking the requirement, we use this formula if the claim is on the population proportion. So what are the rare events? Rare events are the events that the probability of the event is less than 5%. Okay. Since in any hypothesis test, we always assume that the null hypothesis is true at the beginning of the test, when we collect the data and then we calculate the test statistic, which is the z-test or the t-test. And if after finding the test statistic, if we get a very low, very small number, which is usually less than 5%, the result is considered unlikely under the null hypothesis. And that's why we need to reject the claim. And that number is called alpha, or the significance level. Alpha, or significance level, that is the probability of making mistakes. If you remember, when we talked about the confidence interval, we were talking about the confidence level. We always had the confidence level of 90% or 95% or 99% because we wanted to be more confident about the result. But when the confidence level was 90%, that means we still had 10% chance of making a mistake, or the chance of making a type 1 error. And with this is called alpha. If the confidence level is 95%, that means the 5% is left for any mistakes that we may have. And that is the alpha for us. That's the significance level. These are the confidence level. These are alpha is the significance level. If the confidence level is 99%, there is 1% left for any type of error that we may have, which is alpha, and the significance level is 1%. Then we check the result, we compare the result from the test statistic with alpha to see if we need to support the claim or we need to reject the claim. In the problem, always they give usually the problem gives us the significance level. If not, we always assume that it's 5%. Okay. P-value, it's a probability value. The probability that the null hypothesis is true. Okay. p-value method is one method to compare the result and make our decision. So far we said that for a hypothesis test, we need to write the null and alternative hypothesis. We need to find the test statistic if we are going to use a z-test or t-test. After finding the best test statistic, we are going to calculate the test statistic. And after finding the z or t, we need to compare that value with alpha. And this method is called the p-value method. We're going to find the p-value. We're going to find the p-value and compare the p-value with alpha. Okay? And the p-value is the area under the curve. After you find the z or t, since you have a normal distribution, after finding the test statistic, based on the claim, if it's a less than or greater than or not equal to, you will find some part of the area under the curve. And that area under the curve is called the p-value. If we have a left tail test, the p-value is the area to the left. If we have a right tail test, the p-value is the area on the right. If we have a two-tail test, the p-value is the area on both tails because we have two critical values. And half of the p-value is on the left and half of the p is on the right. How do we know that the test is a left tail test, right tail test, or two tail test? Just looking at the alternative hypothesis. Okay? When you look at the alternative hypothesis, if you have a less than symbol for the alternative, that means you have a left tail test. And if you have a left tail test, after finding the test statistic, the area on the left is the p-value. When I look at the alternative, but I see that the alternative hypothesis has greater than symbol. If it's greater than, that means we have a right tail test. And a right tail test means after finding the test statistic, the area to the right of that value is the p-value. And if the alternative has not equal sign, if we have this symbol for the alternative, that means we have a two-tail test. For two-tail test, when you find the test statistic, you have two areas. Some part of the p-value is on the right, some part is on the left. It means that half of the area is on the right, the other half is on the left. And it means that to find the area, to find the p-value, you just need to find one of these areas and then multiply it by 2. So if you have a left tail test, the p-value, that's area on the left tail, the whole area on the left. For the right tail test, the p-value is the whole area on the right. But for the two tail test, the p-value is the 2 times of the area in one tail. So you are going to find the area in the right or the left, one of them only, and then multiply it by 2. Let's look at this example. It says for each claim, state the null and alternative hypotheses, and then determine whether the hypothesis test is a left tail, right tail, or two tail test. Sketch a normal sampling distribution and shade the area for the p-value. These are the same examples that we have in the beginning of this lecture. It says a school claims that the proportion of its students who are involved in at least one extracurricular activity is 61%. Proportion is 61. That's a claim. Claim says that the proportion is equal to 0.61. Since I have equal sign, where do I put the claim? In the null hypothesis. And the alternative must be the opposite of equal, which is not equal to. Now, if I want to know that this test is a left tail or right tail or two tail test, I need to only look at the alternative. The alternative is not equal to. Not equal to means a two-tail test. That means half of the p-value is on the right, the other half is on the left. Second example, it says a car dealership announces that the mean time for an oil change is less than 15 minutes. The mean is less than 15. That's the claim. Mean is less than 15. That's the claim. Where do we put the claim when we have only less than? In the alternative. So the null must be the opposite of less than, which is greater than or equal to. Now, what type of test do we have? Is it the left, right, or two-tone? Just looking at the alternative. Alternative is less than. Less than means the left tail test. So it means that after finding the test statistic, the area to the left is the p-value. This whole area is my p-value. And the next example says a company advertises that the mean life of its furnaces is more than 18. Mean life is more than 18. Mean or mu is more than 18, and that's a claim. Where do we put the claim? For the alternative, because there is no equal sign, so the null hypothesis must be less than or equal. Now, by looking at the alternative, and when I see the greater than in the alternative, I know that I have a right tail test. So this area is my p-value. How do we find the area? Looking at the z-table, looking at the t-table. Okay, now after finding the p-value, to make our decision, we need to compare the p-value by alpha. When you find the p-value, if the p-value is less than or equal to alpha, you always have to reject the null. But if p-value is more than alpha, is greater than alpha, you fail to reject the null. When you reject the null, that means that the alternative may be correct because you're rejecting the null. But when you fail to reject the null, we don't have enough evidence to support that the alternative may be correct. Okay? Let's look at these examples. It says find the p-value for a left tail hypothesis test with a test statistic of z equal negative 2.23. Okay. We don't have the null and alternative hypothesis in this example here. We only know the test statistic, which is negative 2.23. And we know that the level of significance is 0.01. So when we have a normal distribution, the test statistic is negative 2.23. And the question tells me that's a left tail hypothesis test. Left tail test means the area to the left, it's the p-value. So if I want to make my decision, I need to find the p-value first and then compare it with alpha. Okay, how do we find the p-value? By looking at the z-table. Let me see if I have the z-table. No. Okay, when you look at the z-table, look for this number, you will see that the z-table gives you this number as the area on the left. Because you know all the numbers in the z-table are the area to the left. And in this case, also, we want the area to the left. So we use the exact number from the table. After finding the number from the z-table, now this is my p-value. And I need to compare this p-value with alpha. Since this number is greater than alpha, which is 0.01, since p-value is greater than alpha, our decision is fail to reject the null. Looking at the next example. This time we have a two-tail test, and the test statistic is 2.14. So we have a two-tail test. That means we have two z-value. That means this is 2.14, this is negative 2.14, and the p-value are these areas. So half of the p is on this side, the other half is on this side. So you only need to find one of these areas and then multiply it by 2. So looking at the z-table, find this number on the z-table and see what is the area to the left. If you want to use this positive form of the number, make sure that if you're using positive 2.14, you need the area to the right of that. It means any number that you get from the table must be subtracted from 1. But if you use negative z value, any number from the table, that's your exact number answer. So if I find negative 2.14 in the z table, I get this number. If I use positive 2.14, I get this number, and then I subtract it from 1, and again I get the same number. So it doesn't matter which one of those numbers you use. If you use positive 2.14, remember that the p-value is the area to the right, so the number from the table must be subtracted from 1. But if you use the negative 2.14, the exact number from the z-table, that's your answer. But we know that this is the area in just one tail. Well, the p-value is the two tail, so we need to multiply it by 2. And after multiplying by 2, we get this number for p-value. Now, to make our decision, we need to compare this one with alpha, which is 5%. Is this number less than alpha or more than alpha? Since this number is less than alpha, we need to reject the null. Next example. The example about the boy genetics lab, which claims that the procedure improved the chances of boy being born. We have the result here. We have the null and alternative hypothesis, the level of significance, and the p-value also is given to us. Now we want to make our decision and interpret the result. Okay. To make our decision, we compare the p-value with alpha. Is p-value less than alpha or more than alpha? The p-value here is 0.025. It's more than alpha. If p-value is greater than, our decision is fail to reject the null. So you fail to reject the null. When you fail to reject the null, that means since the null and alternative hypothesis always are complementary statements, if you do not reject the null, you have to reject the alternative. That means you are going to reject the alternative, which is the claim. If you reject the claim, that means you don't have enough evidence to support the claim. Okay, so my conclusion is that with 1% level of significance, we do not have enough evidence to support the claim. How do we know if I have to use the word reject or support in my final statement, my conclusion? Let's look at this table. If the claim is on the null, we always use the word reject in the statement, in the final statement. If at the end of the hypothesis test you rejected the claim, rejected the null, and since the null is the claim, that means you're rejecting the claim, so you say, okay, there is enough evidence to reject the claim. But if you fail to reject the claim, you say there is not enough evidence to reject the claim. So anytime the null is on the the claim is on the null, don't forget that you have to use the word reject in both cases. But if the claim is on the alternative, we always use the word support. If you reject the null, you support the claim, the alternative. If you fail to reject the null, you do not have enough evidence to support the claim. Okay, that's very important when you're writing your final statement. Let's look at an example. Suppose a baker claims that his bread height is more than 15 centimeters on average. Several of his customers do not believe him, and to persuade his customers that he is right, the baker decided to do a hypothesis test. He bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters, and the baker knows from baking hundreds of loaves of the bread in the past that the standard deviation for height is 0.5 centimeters, and the distribution of height is normal. State the null hypothesis and alternative hypothesis. Draw a graph that shows the p-value and interpret the meaning of the p-value. Okay. When you read the question, you need to find the claim first. The claim says that the height is more than 15 on average. That means the mean, the average means the mean is more than 15. That's the claim. Now, when you want to write the null and alternative hypothesis, you need to know where the claim goes. Do you put the claim in the null or alternative? Since there is no equal sign, I put it for the alternative. And if the alternative is greater than, null is less than or equal to. Now, I wrote the null and alternative hypothesis. And right now, by having the null and alternative hypothesis and looking at the alternative, I know that I have a right tail test because I have greater than symbol. I know that's a right tail test. It means that if you find a test statistic, after finding the z or t value, the p-value is the area to the right because it's asking you to find the p-value. But if you want to find the p-value, you must have the z, you must have, or t, you must have the test statistic. When you read the rest of the question, it says that he bakes 10 loaves. The sample size is 10. The mean height for the sample is 17. And since he knows from the past studies, or not the studies, actually baking hundreds of loaves in the past, the standard deviation, it means that's the standard deviation of the population. So don't forget that we need to check the requirement. The sample must be random, which it is. The population must be normally distributed, which it mentioned. I have to write the null and alternative hypotheses. We have them here. Now I have to find the test statistic. I told you we have two test statistics, Z or T. Which one are we going to use here? We're going to use Z. Why? Because the sigma is noun. When sigma is noun, we use Z. And the formula for Z is x bar minus mu over the sigma over the square root of n. So the x bar is 17. Mu is, what is mu? What's the mean? Look at the hypothesis. The mu is equal to 15. We always assume that the mu is equal to the claim number. So mean is 15. Sigma is 0.5 over the square root of sample size, which is 10. And the answer that we get here for the test statistic is 12.66. If z value is 12.66, the p-value is the area to the right. But don't forget that you have to look at the z-table and find the area. But all the numbers in the z-table are the area to the left. Then when you find 12.66 on the z-table, whatever number you get from table, that's the area to the left, and you must subtract it from 1 to get the area to the right. But do we have this number on the z-table? No, because the greatest number that we have on the z-table is about 4. And any number greater than 4, it would be the same as 4, which is almost 1. So the total area on the left is 1, and since the p-value is the area on the left, 1 minus 1 is 0. So you see, we got 0 for the p-value. And to make your decision, you need to compare the p-value with alpha. It doesn't mention what the alpha is, what's the level of significance in this example. But since the p-value is 0, 0 is less than any significance level. Even if the alpha is 0.05, if it's 0.01, if it's 0.10, 0 is still smaller than any significance level. And if p is 0, it means that it's less than alpha, any alpha. And if p is less than alpha, your decision is rejecting the null. If you reject the null, that means you're rejecting this one. If you reject that, that means you may be able to support the alternative, because null and alternative always are complement of each other. If you reject one of them, that means you can accept the other one. You may be able to accept based on the evidence. Okay? Now, since the claim is on the alternative, I am going to use the word support. The claim is on the alternative, I'm going to use the word support. And since I'm rejecting the null, my final statement is this. So there is enough evidence to support the claim. So there is enough evidence to support the claim that the bread height is more than 15 centimeters. Okay? And the next example, which is, I believe that's yeah. The next example, the next hypothesis test example, it says that it is believed that the mean height of high school students who play basketball on the school team is 73 inches with a standard deviation of 1.8 inches. A random sample of 40 players, so n is 40, is chosen. The sample mean was 71 inches. Sample mean is x bar. And the sample standard deviation, or S, is 1.5. Do the data support the claim that the mean, that's a claim, the mean height is less than 73 inches? The claim says that the mean height is less than 73 inches. To write the null and alternative hypotheses, where do I put the claim? On the alternative, because there is no equal sign. And then make sure to mention that's a claim. And if the claim is less than, that means the other one is greater than or equal to, or just equal to. After writing the null and alternative hypotheses, now we have to know what test are we going to use. Are we going to use z-test or t-test? This is a hypothesis test on the population mean. For population mean, we have two cases. If sigma is noun, we use z-test. If sigma is unknown, we use t-test. In this example, is sigma noun or unknown? Yes, the sigma is now because it's given to us from the previous studies. The population standard deviation is given to us. So when the sigma is known, I'm going to use z-test. Okay, so and the formula for the z is x bar minus mu over sigma over the square root of n. X bar is 71 minus mu is 73. Mu is always from the claim. Sigma is 1.8 over the square root of 40. And the z is equal to negative 7.01. After finding the z, I need to show the p-value and then shade it in the graph, but you know we have a normal distribution. What type of test do we have? Is it a left tail, right tail, or two tail? Looking at the alternative. The alternative is less than, means when the z-value is here, negative 7.01, the p-value is area on the left because we have a left tail test. Again, we look at the z-table, find this z-value on the z-table, and check what's the area under the curve for that. Is this number in the z-table? No, because the minimum number that we have, the smallest number that we have in the z-table is negative 4. And any number less than that, it's kind of equal to that number, which is 0. Again, we got the p-value equal to 0. And if the p-value is 0, again, is less than any alpha, and if p-value is less than alpha, we need to reject the claim. And if we reject the claim, if we reject the null hypothesis, we reject the null hypothesis. And if we reject the null, that means we can support the claim, which the mean height is less than 73 inches. Rejection region method is another method that we can use instead of p-value for making our decision. So far, we learned about the p-value method. For using the p-value method, for p-value method, we need to find the test statistic, which is z or t. And after finding the test statistic, we need to find the area under the curve from the z or t table. Which is the p-value, and then compare the p-value with alpha. That's a p-value method. So we need to find the test statistic first, then looking at the z-table or t-table to find the area, which is the p-value, and then compare it with alpha. But when we are using the rejection region method, we are going to find some critical values first. Okay, not the test statistic. The critical values are z or t. And how do we find the critical value? We look at alpha as area under the curve. So we look at alpha or the significance level as the area under the curve, and based on this area under the curve, we find the z or t value, which are my critical value. And after finding the critical value, we need to show the shaded area, which is the rejection region. And then we find the test statistic. And when we find the test statistic, we need to check if the test statistic falls in the rejection region or not. If it falls in the rejection region, you reject. If it doesn't, you don't. You fail to reject. So you see that the difference is that for the p-value method, you find the test statistic first, but in the rejection region method, you find the test statistic as the last step. Okay? And let's see how it works. So as I said, we need to find the critical values first. And to find the critical values, we need to look at the alpha as the area under the curve. If we have a left tail test, alpha is the area on the left, and we find a z-score that corresponds to that area. If we have a right tail test, the alpha is the area on the right side. That's the alpha. And to find the z-value, since you're going to look at the z-table, you need the area to the left. So you need 1 minus alpha as the area. But if you have a two-tail test, we know that we have two critical value. That means half of the alpha is on the right and half of the alpha is on the left. You only need to find one of these critical values. If you want to find this one, which is the negative one, you only look at the half of the alpha on the z-table. But if you want to find this z-table, you need 1 minus half of the alpha, because that's the other half. Okay? Why 1 minus 1 half? Because if this area is 1 half, you need the area to the left, which is 1 minus half of the alpha. Let's have some examples. Just find the critical value and the rejection region for a left tail test with alpha is 1.01. Okay. We have a left tail test. If we have a left tail test, that means alpha is the area on the left. That's alpha. I need to find this critical value first. So I'm going to look at the z-table and look for 0.01. So that's a z-table. Look at the body of the z-table and look for 0.01. 0.01 is somewhere between these two. That's right. Or no, not exactly in between. It's closer to this number. Yes. Because this one is just 0.00010 less, but the other one is 0.0017 more. So it's closer to this one. So what's the corresponding z-value? The critical value is negative 2.33. So after finding the critical value, you say, okay, the rejection region now is the area to the left. That's a shaded area. So the rejection region, it's any z-value which is less than negative 2.33, because the shaded area is on the left side of this point. And after finding the rejection region, you need to find the test statistic and check if the test statistic falls in this region. Next example. We want to find the critical value and the rejection region for a two-tail test with alpha equal to 0.05. If it's a two-tail test, that means we have two critical values. So the shaded area are on the two tails. Half of the alpha is on the left and the other half is on the right. Oh, it's just one. Yeah. Okay. So now you're going to look at the z-table, look for this area to find the critical value, the negative one. After finding the negative one, you can do the same, use the same number for the positive. So if you look at the z-table and try to find the 0.025, you get this number. And you see the corresponding z-value is negative 1.96. So this number is negative 1.96. That means the other one is positive 1.96. And if you want to show the rejection regions, because after finding the critical values in the rejection region method, you need to show the rejection region. Rejection regions are the shaded area. And these area are this part, the left side, is all of them that are less than negative 1.96. And the right side tells me all the numbers that are more than positive 1.96. Both of these areas are in the rejection region. And then I try to find the test statistic. After finding the test statistic, after finding the number, if the number is less than negative 1.96, I reject. If it's more than 1.96, I also reject. But if it's not in those regions, I fail to reject. So in the next video, I will show some examples with the full hypothesis test.